Okay, let's go through number. Hang on. Let's go through number 4, and then we'll go through number 8 and using proportion. There we go. Okay, so you are going to fill in the blanks for me. For number 4, we have. I wrote down the information, didn't even read the problem, so let me go back and read the problem. We're talking about distances traveled to work in the Cincinnati and Pittsburgh office. We have a sample of 35 for Cincinnati, so the travel mean of 370. So for Cincinnati, the travel mean was 370. For Pittsburgh, it was, what was it? 380? Okay, thank you. They want to know, is there a difference in how these two are compared, not necessarily which one's bigger or smaller. So they've given you the standard deviations of 30 and 30 or 26. I think I have that right. Do I have that right? Okay. We have a 0.05 significance level. They want to know, is there a difference? So that's my key word there. So is this a one-tailed or two-tailed? Two. So I want to know, is there a difference? They're the same. Remember, null means nothing changes. Zoom in. And then the other one would be not equals. So then step 2. Want to know what's the significance level? They tell you that in the problem. Sometimes I'll give you all these steps and say, now fill in the blank. So even though it's okay, oh, I don't have a calculating thing, make sure you fill that in. Don't assume that I know to look back. For step 3, you want to know, what do you reject the null at? If it's bigger than what? So what do I do? It's 0.05. It's a two-tailed test. 1.96? Oops, 6. I can write this correctly. Okay, for step 3, so I know if it's bigger or smaller, because remember I want it to be positive or negative. 1.96, then I would reject my null. So then the next one, I want to use the z-value. And let me move this one under here. I can't see. Then I need to calculate my z. And remember, I'm using the two populations comparing. So I want to flip back and look at my z-score. How do I calculate it? What would go on the top? So I already know it's going to be a negative answer. No big deal. Okay, what goes here? 27. And then, 26? I'm sorry. Okay, what about down here? 40. Okay, and I should come up with, since I didn't calculate it, tell me if y'all got this one. Or something close. Is that close? You didn't? Okay, and that's okay. If it's because you put it in the calculator wrong, at least you're getting how to do this part, so I'm not worried. That's why I always do stuff by hand, even though it takes longer. So I get this, but I just said my cutoff was 1.96, so what do? Do not reject the null, so do not reject HO. So that means that HO, even though we're not technically saying it's true, most likely it's true. So, okay, there's not a difference. They're pretty much the same driving time or mileage or whatever it was. Now for number 8, I want to go through especially how to set this up. They've given you the information in this problem as far as the H1. So for number 8, they've given me the null and alternate hypotheses right here. There's a sample of 200 observations from the first population. So X1 has a sample of 200. X2 has a sample of 150. They've told me that there's a the proportions in here. So they've told me this is 170 out of 200, if y'all can even see that. And that this one's 110 out of 150. We'll go back to that in a minute. So the first thing you need to do is figure out what the P of C would be, and that's what they've told you, I think, in part B. The P of C is going to be the x1 plus x2 divided by the n1 plus n2. Here they've given you the n of. They've given you the n's over here. So I'm just plugging this in. 170 plus 110 divided by 200 plus 150. And I think I moved the decimals along. Let me find it. Yeah, it's 0.8. 0.80. I was writing fast. Yeah, 0.80. So that does not sound right at all. Okay, then the next thing I want to do is figure out what the z is going to be, and this is my z formula for the proportion. The proportion of first one, proportion of second one, and then I'm plugging in this P of C all throughout here. So these right here will be the same. This and this will be the same for both of these calculations. I'm just dividing by different ends. So these only two that will be different, which is what I have up here. To figure out what my proportion is going to be, I have 85 and 73.33. I figure that out over here. I take the 170 out of 200 and 110 out of 150, and I've come up with my proportion. They don't necessarily give it to you. Sometimes they do in the problem. But if they don't, know that I need to come up with some sort of a decimal proportion somewhere. So I'm plugging those in right here. And then the next part is going to be plugging in this P of C times 1 minus the P of C. The P of C, the pooled one, was 0.08, so that means subtracting it from 1 would be 0.2. 0.08 or 0.8.2. Then I need to plug in on the bottom the 200 and the 150. 200 and the 150. I calculate all of this and I come up with a z of 2.7. What is going to be my cutoff at a two-tailed at 0.05? What is it? 1.96? So would I reject or not reject this? I would reject the null and say, whatever, there is a difference in these proportions or whatever it is. So I'd say that this one's going to be true. So this is how you set it up, the steps that you'll go through. The hypothesis testing steps are going to be a little off because you're dealing with proportions rather than the actual numbers, but it's the same basic concept that you're going to be going through this and coming up with an end result that you compare to a set standard, and I either reject or do not reject, and then what does that mean, putting it in words. So this will get you started on chapter, ready to finish up chapter 11. And then chapter 12, I want you to look through it so we can go through examples and other issues that you have on Friday.